Hello YouTube. I made a post on Reddit which got 70,000 views and 300 likes. So I decided to convert it into this YouTube video as well as to post others in the future. So in this video, I'll focus on the best practices for model fine-tuning, large language models, specifically so that it's better to be able to verbalize when it doesn't know something. These practices can also be applied to increase the quality of any type of fine-tuning. I work with 7 billion and 13 billion open source models, as these are easier to rapidly experiment with and they don't break my hobbyist budget. So let's start with the simplest case. Here's an example prompt from Mistral 7B OpenOrca, and the answer it currently gives. So when you prompt it, what is a Blinrog offset? The answer is a Blinrog offset refers to the adjustment made in a game or simulation when dealing with a Blinrog creature. The term Blinrog comes from the popular video game series, The Legend of Zelda, and so on and so on. So the model, of course, completely hallucinates because the word Blinrog is completely made up. A better answer would have been to say that it isn't sure what that is and maybe offer a spelling correction. So our simplest fine-tuning QA, question-answer pair, would be something like, what is a Blinrog offset? I do not recognize this term. Perhaps you could provide more context. That's pretty good. Just as a note, this and the following QA pairs will be the ones used for fine-tuning and not the responses of the current model before training. So if you generated thousands of these question and answer pairs, you would get the bulk of the fine-tuning done. However, this wouldn't give you spectacular results. So let's have a look at possible improvements. The word Blinrog was specifically selected so that it isn't very similar to other existing words in the English dictionary. It's also important that this word really doesn't exist. So when you are creating these questions, it's a good idea to use Google just in case, so you don't confuse the model with something it might actually know about, or an obscure word. If it knows something about it, then it's going to try and explain it. So one reason you want to pick imaginary words which are very different to all other words, i.e. large Levenshtein distance, is because small models are capable of figuring out spelling mistakes, and suggesting spelling corrections in their answer is desirable behavior. So another good fine-tuning QA pair would be tell me about the fibrillating exhaust manifold used on DC-10 rockets in the 1960s. The DC-10 is an airliner, not a rocket, and was first flown in the 1970s. There's no known technology called a fibrillating exhaust manifold associated with it. So that would be a good answer. So the prompt is nonsensical, but close to a valid question. Here you're teaching it that it can use association of terms, but under certain patterns, it should be able to distinguish between plausible sounding context from factual context. So this activates a pattern recognition, which will be similar when it is about to start hallucinating. And this level of fine-tuning might be too much for a small model, 7 billion model, but it's worth a shot. For smaller models using non-imaginary words in nonsensical sentences like this might be riskier because distinguishing what is sensical requires more information and context and so on. And this is in turn might require more complex activation patterns, and which small models might struggle with. Next, you might want to include a QA pairs such as who is Michael Jackson and Smorgle Dorgle. The good answer would be Michael Jackson was an American singer, songwriter, and dancer. Smorgasbord does not refer to a known public figure, and it could be a fictional name. Well, here it is again learning to distinguish between known and unknown data and how to respond. When writing answer prompt, the known part should be very similar to the answer the LLM would give you if you only asked about the known subjects, in this case, Jackson. So by teaching it to distinguish between known and unknown pair of terms, this ability should scale up to 3 or more terms automatically. However, for best results, you would want to include longer QA pairs with multiple known and unknown subjects. Unknown subjects is like just imaginary stuff. So then you should also include 2 spelling mistakes, not 1. For example, what is a role of DNA and hereditary? I don't know. Perhaps you meant DNA in relation to heredity. The role of DNA is so on and so on. This further enforces, the need to gravitate towards known terms and err on the side of caution with regards to interpreting unknown words. So this should also make the model harder to slip into hallucination because it will have incentive to walk the shorter path to obtaining terms grounded in reality. So if it's not sure exactly what the thing is, it will try to correct itself towards something real and then explain from there. So, so what is the hypothesis on why any of this should work? Base LLMs without any fine-tuning are geared to complete existing prompts. When an LLM starts hallucinating or saying things that aren't true, a specific pattern appears in its layers. This pattern is likely to be with lower overall activation values, where many tokens have similar likelihood of being predicted next. The relationship between activation values and confidence, that is how sure the model is of its output, it's complex. But a pattern should emerge regardless. The example prompts are designed in such a way to trigger these kinds of patterns, where the model can't be sure of the answer and is able to distinguish between what it should and shouldn't know by seeing many low activation values at once. Or it's not strictly low activation values, it's more of like certain patterns. It's too complex to know for sure. So this, in a way, teaches the model to classify its own knowledge and better separate what feels like hallucination. In a way, we are trying to find prompts which will make it surely hallucinate, and then modifying the answer to be, I don't know. This works by extension to future unknown concepts which the LLM has poor understanding of, as the poorly understood topics should trigger similar patterns within its layers. You can, of course, overdo it. This is why it is important to have a set of validation questions for known and unknown facts. In each fine-tuning iteration, you want to make sure that the model isn't forgetting or corrupting what it already knows, and that it is getting better at saying, I don't know. You should stop fine-tuning if you see that the model is becoming confused on questions it previously knew how to answer, or at least change the type of QA pairs you are using to target its weaknesses more precisely. This is why it's important to have a large validation set, and why it's important, it's probably best to have a human grade the responses. So if you prefer writing the QA pairs yourself instead of using ChatGPT, you can at least use it to give you two, 3 or 4 variations of the same question with different wording. This technique is proven to be useful and can be done on a budget. In addition to that, each type of QA pair should maximize the diversity of wording while preserving the narrow scope of its specific goal in modifying behavior. So just, in other words, say the same thing in as many different ways as possible while saying essentially the same thing. Will this work in practice? When the LLM is about to start hallucinating, its activation values show one kind of pattern. When the LLM is about to retrieve one bit of information from the far-flung neurons of its subconscious, the activation values show a different kind of pattern. So how well this technique works relies on how different those patterns are. There is a way you can test how well the LLM knows what it doesn't know. You first need a very hard question. If you know the training data, the ideal question would be about a fact that appeared only once in the training set. If you don't know the training data, just take a best guess on what a difficult question might be. Now, if you ask the same question 100 times with non-zero temperature, and the model hallucinates 10% of the times, that means that it knows what it doesn't know 90% of the time. And in my limited testing, I could never get Mistral 7 billion model to hallucinate about a fact it actually knew. So it was 100%. This indicates that the patterns triggering hallucinations and deep knowledge retrieval are different, and thus that the model should be trainable to distinguish between the two. And also note that trainability is not the same as effectiveness. If the two patterns overlap at 30% of their features, that means you're likely only going to get to be able to reduce hallucinations by 70% before the model starts saying, I don't know, to things that it does actually know. So this is not an exact science. It requires empirical testing, multiple fine-tuning iterations, and probably a bit of manpower. Because LLMs are black boxes, so this isn't an exact science, and with the current architecture, it probably never will be. Finally, do I think large models like ChatGPT-4 and Claude 2.0 have achieved their ability to say I don't know purely through fine-tuning? I wouldn't think that is very likely, but it is possible. There are other things, more advanced techniques they could be using and not telling us about, but more on that topic some other time. Actually, probably in the next video. So yeah, thanks for watching.